Hello class, this is Building Construction for the Fire Service, Chapter 12, Firefighting Concerns of Green Construction. This chapter explores the concept of green or sustainable construction. It provides an overview of different categories of green construction, materials used, and firefighting concerns related to each material. The objectives we're going to cover in this class are as follows. We will define green or sustainable construction and explain the role of green certification rating programs and green construction regulations. We will also identify and describe the 4 general categories of green construction, identify firefighting hazards associated with each type of green construction material or green building system. Green construction is a relatively new term, but use of environmentally friendly technology is old. Some examples of older methods include sod-roofed houses, windmills, and water wheels. Now, sustainable construction is construction that is deemed to be energy efficient and environmentally friendly. Do not assume that all materials used in green construction are quote-unquote natural. Synthetic materials that conserve energy may well be used. Now let's talk about leadership in energy and environmental design, also known as LEED or LEED. This is a rating program by the U.S. Green Building Council. Its stated objectives are to lower operating costs and increase asset value, reduce waste sent to landfills, and practice conservation of energy and water. And construction should be healthier and safer for occupants. Their objectives also include reduction of harmful greenhouse gas emissions and people that use this type of construction qualify for tax rebates, zoning allowances, and other incentives in hundreds of cities, and all of those are objectives of LEED. Here's another thing you need to know about a program called the Building Research Establishment Environmental Assessment Program, and its acronym spells out BREEAM. It's a worldwide program, and it assesses the quote-unquote greenness of buildings. The code enforcement community plays a role here. Fire rating systems don't deal with fire issues. And the 2012 International Green Construction Code issued attempts to regulate green construction. And there's a coordination with the International Building Code and the International Fire Code to help with fire rating systems in green construction, which is, though we mentioned how many of the materials and even methods are old, there has never been such a movement worldwide to push green, environmental friendly construction on the kinds of levels where we now have nationwide and worldwide standards. Some of the hazards with green construction is to remember that traditional hazards still exist, like electrical systems, for instance. Maybe it's solar, but you've still got batteries and transformers and wiring that you're dealing with. And there is a possibility that your fire ground hazard may be increased. So don't equate green construction with increased safety. They don't always go hand in hand. Now let's talk about some of the eco-friendly materials or green materials. One of the most popular and increasingly used materials is bamboo. It's a quick growing plant, so it's a resource that's able to be harvested quickly, and it's used for everything from furniture, structural laminated beams, curtain wall panels, to trusses. And now it's used quite a bit in flooring as well. Currently, there's no ASTM E119, the standard we talked about in chapters 10 and 11. They don't have a test type in that standard that exists currently for these eco-friendly materials, but in this case specifically bamboo. One thing with bamboo is you can expect earlier failure. Remember that even though it can be made durable and strong, it's very strong on its own, and it may be finished and aged so that it's strong enough for flooring and beams and things like that. It's still ultimately, it's actually a plant, so it doesn't even have and like I said, there's no test that's rated bamboo yet, but it doesn't have the knowledge that, well, we don't have the knowledge about bamboo as a building material than we do about wood, and it ultimately doesn't have quite the strength that wood has overall, which is why you don't see beams being made out of bamboo, for instance. So expect early failure. Another eco-friendly material is adobe, which is a composite material and it's made with clay, fibrous substance, sand, and earth. And it is baled into bricks, adobe bricks. And then there also now is the use of straw bale. Straw bales that are covered with cement or earth plaster have been integrated into construction, and worryingly for me anyway, it is being used sometimes for insulation. I have some concerns about that, but to address some of the issues with straw, you'll find these bales that are covered with cement or some kind of earth plaster, but the loss of coating exposes straw to fire. And anybody that knows anything about fire, or a common man on the street, can tell you that straw burns extremely rapidly, which is one reason I have such reservations about being used as an insulating material, coated or not, but especially even coated. Then you have another material called cob, which is similar to adobe, and it is a composite of clay, straw, sand, and earth. And it is laid in courses and may have plaster added. We also have biopolymers being used as an eco-friendly material, and biopolymer is a green plastic, quote unquote, made from renewable living sources, and is used for insulation, building blocks, lumber, roofing shingles, and tilt-up walls. One has to remember that fire testing and experience with these materials are lacking, and part of the reason for that is there has been such a large influx of these materials that ASTM and NFPA, NIST, etc. It takes a while to build up proper testing and all different modes of how these materials are used, and build up test in accordance with each of these. And so it takes a while to develop all of that before even proper testing and experience from that testing can be developed into codes and standards. Another eco-friendly material, believe it or not, is ammonia. It's an old refrigerant from the 1870s, and ammonia is extremely hazardous. And in the old refrigerators, when it was used as a refrigerant, if the system, it's a closed system, but if there was a leak in the line, there literally were hundreds of people that died from early refrigerators, and slowly the firefighters and investigators began to put together that since it was a closed system, in other words, it wasn't vented to the outside, if there was any type of leak in the line, people could be poisoned from it. And it also is extremely flammable and even explosive. So even though it was used originally as an old refrigerant from the 1870s, it is still used as a refrigerant and is now a primary refrigerant for large-scale systems. And the reason for that is because of its ability to extract heat, which is the primary role of a refrigerator, and it is used in combination with other types of refrigerants. So it's not straight ammonia like the earliest refrigerators. And the systems we have to contain refrigerants, those systems have improved dramatically, but it is still used. So that's definitely something you need to remember, and that it has not only a toxicity hazard but also an explosion hazard, and will burn at as low as a 16% concentration. So that's definitely one material that it may be considered eco-friendly, but I literally never see it that way. I respect it from a fire standpoint, which, it's a pretty dangerous material. Let's talk now about energy conservation. Synthetic insulating materials save energy, but they are toxic when burning and are difficult to recycle. Vegetation as insulation saves energy, but if it's dry, it's combustible. Some other measures that are taken to be more green in terms of energy saving are one, which is polystyrene insulation, and this is a spray applied foam or used as a rigid plastic insulation. And it may be energy saving, but plastic, when it burns, is really bad news because it gives off serious toxic fumes, and sometimes a multitude of toxic fumes, and can generate a lot of smoke. And with polyurethane insulation, there's often also a rigid plastic insulator, so it can be used singly as an insulation or a plastic insulator. Sometimes it's actually used as both. It is often used as, or used in stud channels in walls. There are also radiant barriers. These are flexible reflective membranes that are added to attic spaces to reflect heat. Glass can be used as an insulating material, but daylight involving increased use of glazing means that this increased use of glazing helps to light spaces naturally without quite as much radiant heat and glare. And when we say glass is insulated or used as a means to, when it's used as an insulating material, this glazing, one method is the energy efficient windows you see going into new homes where you have sealed glass, which means that there is an exterior piece which often has some kind of coating to help block UV radiation and also just some of the heat. Then you have a thin center membrane And then the inside piece, which also has a glaze of UV protection. So that's wonderful because it does help eliminate heat or reduce the amount of heat you get from the same size single pane window of an older style. So people use it, it allows people to have their curtains open in the daylight without the house heating really rapidly, and you're able to get more natural daylight into the house. But these vacuum sealed windows are harder to break, so when you're trying to enter a house and you have to break a window, that's something to bear in mind. And also the materials and coatings involved can smoke badly and cause serious problems as well. And green roofing is a method of roofing which uses vegetation and materials to support plant growth. And that's actually wonderful because it does allow plant growth to keep area more green. The less concrete and asphalt that can be used, it reduces the ambient temperature in a given area and helps to naturally reduce the interior temperature of the building. So again, that's done with vegetation and materials to support plant growth, but it involves a complex set of layers and creates substantial weight. So you have the earth that it's planted in, the weight of the green materials depending on plants and vegetables that are used, but you also have water involved because it has to be irrigated or fed water source somehow, and that's a lot of weight. And because of that, all of those things may lead to collapse. And there can be a problem with ventilation as well. Buildings have to breathe, obviously, and if you seal a building up too tight, you literally cut off oxygen getting into the house or the building. And if the plant materials on this type of roof are not kept green and they get dry, you can end up with what's known as like a mini wildland fire, because it ignites and it's going to burn like a wildland fire would burn. Now, walls, as we know from covering previous chapters, can influence fire behavior. There has actually been little actual fire experience with green walls. So if you're in a situation where you encounter this, rely on your intuition. And then heavily insulated walls. I just talked about literally over-insulating a building. And you're going to encounter at some point, and this is in the mode of energy conservation, you're going to wind up encountering heavily insulated walls. And these are made with structural insulated panels, and there can be studless wall assemblies. These are made as studless wall assemblies using a core of polyurethane. They're designed for energy efficiency, but you have to remember that these super insulated panels are highly combustible. Polyurethane smokes tremendously and gives off a lot of toxic gas when it's on fire. And they're prone to collapse because there is no, since it's quote-unquote studless assembly, there's no framing under there to hold it in place. So you need to know that green walls and heavily insulated walls can collapse on you, and that they are, again, highly combustible. Continuing with heavily insulated walls, you also can encounter structural insulated sheathing. It's installed as an exterior sheathing in wood frame dwellings, providing structural stabilization, insulation, and as a barrier to moisture. Even with a low ASTM E84 fire spread rating, it still provides fuel for a fire. Its sprayed polyurethane foam insulation fires can occur during actual application. So you won't only find it on the fire ground, it can also certainly be ignited during application and construction of the dwelling. Now we're going to talk about some materials known as green concrete. The first one is what is called an ICF wall panel systems. ICF stands for Insulated Concrete Forms, and they have a lot of advantages. One of them is that it can make a house or a building waterproof and airtight, and those are both good things. However, airtight is a problem, especially if there's a fire involved, because since the building doesn't breathe on its own quite so much, it traps a fire's heat inside the building or the house because it's airtight, and that interior temperature will skyrocket. The next type of green concrete we're going to discuss is what's called a trombo wall, and this is actually kind of a cool system. It's a set of glass exterior panels and concrete block walls, and there's a void space between them. So this is actually glass that's purposely not insulated and all of that, because the heat comes in through the glass and is trapped by the concrete wall behind it. So there's a void space between them, and it's neat because it traps sun-heated air and delivers it to adjacent living spaces through a series of one-way vents. So it's a great way of providing natural heating without using, gas to run a furnace and things like that. However, it is still a void space, and it's going to be pretty warm in there. So there are some fire ground disadvantages, but it's a pretty benign type of system, and the materials are fairly stable, but you still need to know about it. You need to know that it's there and that it can get really hot in that void space, and you need to know, of course, that there is a void space. The next is what's called a double skin facade, and the biggest problem with that is it provides a vertical path for fire, and vertical path, as we know, can be hazardous because it gets up into void spaces and attics and ceilings, and fire can really run amok in an area like that. So if there's a vertical path for fire to get there even faster, that is a potential drawback. Now we're going to talk about Chia Buildings, and this one always makes me laugh because they're called Chia Buildings because they're covered with ivy and vegetation, and they got that name Chia Building from Chia Pets, which does always make me laugh. But these are also used, they're ivy and vegetation material covered buildings, but now it's also used as wall coverings, and you can expect plants to aid in fire spread, especially if they're a little on the dry side. Then you have biofilters, and these are plants that are part of the air handling system. But again, they are plants, so burning plant material can spread fire and smoke through the HVAC system. In the past 15 to 20 years, you've seen material come about that's known as plastic lumber, and it's basically made from recycled plastic, and this recycled plastic waste is used for decks, boardwalks, furniture, trash cans, and things like that. It's great because it's made from recycled plastic, but you have to remember from a fire standpoint that its combustibility is the same as the original material it was recycled from. So it is eco-friendly, but on the flip side, when you're dealing with a fire and that material is present, you're going to have that high combustibility rate, and the smoke hazard and things like that as the original material that it was recycled from. Let's talk a little bit about firefighting accessibility and green construction. There is now widespread use of trees and shrubs to shade buildings, and that is great, but it may impede firefighting access. So that's something to bear in mind. Also, you might see drive zones or fire zones that use materials other than regular road pavement. And so any type of material other than asphalt, like pavers or anything like that, should be inspected and tested for fire access roadway materials. That's not the role of the fire department. It's the role of, city planners and construction contractors and things like that. However, it is important to know that you may encounter them, but there is responsibility at some point for any material other than asphalt, to be inspected and tested to literally hold the weight of a fire engine, but also allow that engine to roll safely and smoothly. Also, there are community walkable streets. However, they may restrict firefighting access as well. In some downtown communities, you have areas that are now pedestrian only, places where they have open air markets all the time, or it serves as just a pedestrian area to walk and shop and even live in. There might be apartments off of that type of complex, etc. However, these community walkable streets can restrict firefighting access just by the fact that there probably isn't a solid road that goes through there. So you have to know your area and know where fire engines are supposed, because you can't build it with no fire access at all, but you need to know where the fire roads and fire entrances are. One good step for water conservation is the presence of or a trend towards using rainwater collection and what's known as gray water. Also, if you know anything about camping, gray water is like the water that's collected from taking a shower or washing your hands. Nothing from toilet or sewer lines, but either rainwater or gray water. And that's all great because it does conserve a lot of water usage, but this requires tanks. And especially if it's rainwater, these tanks can be up on the roof of a building or on some type of elevation, so that gravity can feed the water use out of that tank. So be aware of the dead load involved. If those tanks are full, especially, they're going to be very heavy. So make sure that you're aware of the use of those tanks and whether or not they're present, and be aware also, always just assume they're full, because the more full they are, of course, the more heavy they're going to be. And I just mentioned gray water, and gray water is wastewater from industrial processes, laundries, and other sources that I mentioned, like showers, hand washing sinks, etc. This is more commonplace for firefighting. It's becoming more commonplace for firefighting use, but you need to not confuse black water, which I mentioned, that is sewage, and you need to be aware of black water tanks and gray water tanks, and they should be properly labeled. And you really want to make sure that you're hooking up to a gray water tank. And anytime you've used gray water, and there's perfectly fine to use for firefighting, you need to make sure that all apparatus are flushed afterwards with potable fresh water. Also, ensure that the fire apparatus access roads do not have water tanks below the driving space, which you may encounter as well. Along with all of the eco-friendly and environmentally friendly and green types of construction, you now have energy generation on site. So more and more Americans, and indeed countries around the world, Americans are installing their own energy generating systems, and these are a variety of different systems that are available. The first we're going to talk about are roof solar systems, and these are made up of what are called PV roof panels. These incorporate individual semiconductor cells that react to energy from the sun and generate direct current, or DC electricity. And these systems are now being incorporated not just at home on the roof of a house, but now into roofs and wall building surfaces, or they may be freestanding on their own. You may have seen what's known as a solar farm, where you have just row upon row of solar panels that collect heat and provide electricity. But especially in the western United States and southwestern United States, although you're starting to see it in other parts of the country as well, you've seen parking areas that have awnings or shade over them, and especially the new ones now, it's what was just wasted space is now being used for energy conservation or energy generation. So they'll be covered with solar panels or PV roof panels. And because they can be incorporated not just on the roofs of all types of different structures now, they may also be incorporated, as I mentioned, into roof and wall building surfaces, or maybe freestanding. And you need to make sure you locate these systems before an incident occurs. So know if there's a solar farm near you, know where it is. Be aware of whether or not a neighborhood has houses with roofs covered in solar panels, things like that. Potential hazards you might encounter in an environment that's using self-sustaining energy generation are electric shock, of course. There's dead load weight, the weight of the panels, and some of the apparatus that go with them. And if there's a penetration of these panels, there may be a release of hazardous materials. And you've got to also remember that the electricity is generated and then stored in a small or even a large battery farm. So make sure you're aware and remember that those batteries are going to be pretty close to the area where the energy is being generated. Some firefighting precautions is to make sure you do not break or cut through PV or solar panels or any of the associated equipment completely. Definitely make sure before you do anything that the system is de-energized. This includes the inverter, and that's the system device used to convert DC into AC that's used by the building. So it generates DC, but everything is built to an AC standard. So you need to make sure that the inverter is turned off and all power is turned off. And then make sure you also verify that there are no other electrical supplies for the building. Sometimes with houses, they'll be off the grid where they generate all their own energy themselves, or you'll have a house that is still hooked up to the grid, and that what happens is if there's a period with a lot of snow or a lot of storms or a lot of cloudy days where there's little to no energy generation available because the sun is obscured, the house will convert over onto the grid. So that is another electrical supply you have to be concerned about. Some recent fire incidents involving PV panels is one fire that occurred in 2010 in Bakersfield, California, where firefighters were unable to de-energize the system. In 2012 in Trenton, New Jersey, workers prematurely activated the system. And in 2013 in Delano, New Jersey, the largest PV panel related fire in U.S. history occurred. Definitely take the time to look these incidents up and read about the details of each of these incidents so that you're well educated and prepared to deal with them being present at a fire scene. Make sure that you are aware of conduits and conductors. Locate conduits and avoid them, and they may not be labeled. Now, especially in very recent years, you've got the advent of not just large PV panels, but what are called solar shingles or PV shingles. These are building integrated photovoltaics. So in other words, they serve not only as individual shingles for energy generation, but also serve as the building's shingle system itself. So these are building integrated photovoltaics or PVs. There can be a ventilation problem for firefighters when there's a fire involved with a building that has these in place, because you can't just punch through them like you can a regular roof to ventilate a fire. Also, they are extremely slippery, so once water gets on them, they're much more slippery than regular roof shingles and other roofing surfaces. And as I mentioned, it is just not safe to just break the panels. And sometimes these have been installed retroactively. In other words, it's not the original shingling system that came with the house, and someone has gone out and put a whole bunch of PV shingles on their house, for instance, and have not considered the increase in weight. And so, and make sure you consider it also as a firefighter, because if they haven't considered the extra weight, and even if they have, if there's a fire that has broken out, that extra weight may cause premature collapse. And with PV shingles, they may remain energized when the sun is shining on them. So you can cut off all the power that you know about, but because of the way PV shingles work, they may remain energized themselves individually. You also have a new technology called flexible laminate solar panels. These can be applied to buildings, boats, and even tents. And they're pretty neat because they're literally just flexible solar panels, which are very light in weight and are being increasingly used in RVs and all types of places you'd never be able to use solar energy before this technology came about. But as far as firefighting hazards, the same rules apply as the rules are set up in terms of PV panels and PV shingles. So you've got the same hazards. You've got inverters, battery storage for energy, and energy generation storage, and so forth. And I mentioned completely off-grid systems, and these are PV systems that are not connected to a traditional public electrical grid, and these are often located in rural areas, but you have the same problem as you have with PV panels. And you have an additional problem of not only is there battery storage like we discussed before, but large scale battery storage, because they're completely off the grid. So they can go for several days with heavy cloud cover and still depend on energy that was generated and stored into a battery system. But these batteries are very much larger in scale, or you've got very many more of them. There, of course, always is an electrical shock hazard and a possibility of hydrogen gas generation if a fire breaks out with an off-grid system. One of the newest technologies in terms of energy generation that we see are roof-mounted wind turbines. We've seen wind turbines in fields and things like that, but this is pretty new. These are roof-mounted wind turbines. They're very much smaller, of course, and are used to convert kinetic energy or kinetic wind energy into mechanical energy. But you have some similar hazards as you do with PV systems, because they generate energy, so that energy's got to be stored into batteries for later use, and then you've got wiring that goes into the building while the blades are turning. But one added danger that you have that you don't have with the PV system is these spinning turbine blades. So make sure you know where all of them are, because there may be quite a few. So locate them all and be aware that they're there. There are also solar water heating systems, and solar water heating systems harness the sun's energy to heat water or some other type of fluid. And active systems use a roof-mounted collector, pump, and heat exchanger. Passive systems use a batch collector. Roof-mounted tanks increase substantial dead load. So be aware of what you're looking at too when you roll up on a place. And I've mentioned in the past, knowing your fire response area. Note where locations are that have roof generated wind turbines. Know where PV shingles are in use, or PV panels are in use, or solar water heating systems are in use. Know your area so that you can be aware of potential hazards should you ever have to respond in any one of these areas that have any one of these systems. And they can look very similar, so you definitely need to get out and know your response area. And when it comes to solar water heating systems, remember these lectures are simply to supplement the text. Read the text and even read outside resources so that you can collect good information and much more detailed information about each of these systems, specifically what they do, how they perform, all of the equipment that comes with each of them, etc. So let's summarize everything we've gone over in this chapter. We talked about the fact that green construction is proliferating in response to environmental and energy concerns. The materials used in green construction are not necessarily natural materials, and we definitely talked about quite a few of those. And I mentioned, and make sure you remember, to not equate green construction with safe construction. They are two different things. From a firefighting perspective, green construction can be categorized into 4 categories, and we talked about each of these: eco-friendly materials, energy conservation, water conservation, and energy generation. Each green construction system and material presents different potential firefighting hazards, and as I just was speaking about a moment ago, pre-planning is key to locating, identifying, and understanding those dangers. And you need to know not just in terms of green construction or eco-friendly construction, etc. You need to know it about building construction, about all the things we've talked about in previous chapters. So definitely get to know your area of response and specifically be familiar with green or eco-friendly construction and energy generation, because all of those things are growing very rapidly, and the use of them is growing very rapidly. I hope that this was helpful for you. As I mentioned a couple of moments ago, make sure that you read your text. This is meant to supplement your understanding of what you learn in the text. Use outside resources as well so you can understand some of the specifications and answer any questions that the text may not cover for whatever reason. And definitely use outside resources to look up the incidents that I mentioned in this chapter so you have a really good understanding of exactly what went wrong so that you are more prepared should you have to respond to an incident that is similar and you know what the inherent dangers and hazards are. Thank you as always for your time and attention. And if you have any questions, please make sure to contact your instructor. Again, thank you, and we'll see you next class.